Hello and a very warm welcome here to the Parker booth at Bauma 2025. Parker Hannifin is proud to be the global leader in motion and control technologies. And here at Bauma, the motto is technology inside that moves your world. Parker is here to fulfill your wildest engineering dreams and to partner with OEMs for mobile machinery and off-road applications. What that means is together, we want to help you find greater efficiency, improved safety, and also improved intelligence in your off-road applications, and all that while at the same time reducing emissions. No small task, lots to think about. Here for our live talks, we have gathered our top experts from across the globe to share their insights on 4 key themes that we see are focusing, the industry is focusing on. Those are electrification, digitalization, clean tech, and mobile hydraulics. And you'll see the Parker products and solutions across those 4 themes here at the booth, which you can explore together with our experts afterwards. This talk will focus on smart valve architecture. And you as a design engineer or as a procurement specialist will find out how this can improve performance, energy consumption, and even operator productivity through this smart valve architecture. Enough from me. I'm delighted to introduce our experts all the way from Sweden. First up, he is the electrification expert here at the booth at Parker at Bauma. He leads the application engineering team, and they support Europe's largest OEM customers with their hydraulics and electrification projects all across Europe. Please put your hands together to welcome Erik Forsberg from Sweden. Hi, Erik.
Thank you.
Our second expert, also from Sweden, and they work closely together, but he manages research and development at Parker's Mobile Hydraulic Systems division, both of them in Borås. And you work closely with customers to improve current and develop new technologies. All this while balancing productivity, performance, and costs. Fantastic. A very warm welcome, Johann Hansson. Thank you for joining us here.
Thank you.
So let's dive in. Taking a good look now at the hydraulic system architecture, it seems a lot of people think that is complicated. Is it?
I would say yes. I mean, a lot of the hydraulics is still quite complicated. I think we can always ask, is it smart enough? I think when we look at this picture, I really love this picture. I mean, this is the essence of hydraulics. Really strong, lifting heavy logs. I mean, this is what we've used to see quite a lot. But is it very smart? Probably not. I mean, we're looking into how can we make this really nice function become smart and intelligent. By making it intelligent, we can make it much more flexible indeed. We can make it safer. We can make it easier for the operator. And I would like to ask, I mean, we got a lot of experts here, I think, as well, when it comes to hydraulics. What else would you see when it comes to smart hydraulics? What would you say? Any benefits you could see from smart hydraulics? Any hands up? I know there's a couple of experts over there. Johan, do you want to add something?
No, I think you cover it quite well.
Yeah. Okay, fair enough.
So when we're looking at smart valve architecture, is it complicated, Erik?
You take the complicated part of the hydraulics, you make it simpler, and then you move the complicated part into the controller. That's basically what we're doing.
And remind us again, why are we doing this?
To gain a lot of benefits from it, for sure. Like we said, you can get it safer, simplify the system, the hardware of it, and other things. Yes.
Okay, well, going into those benefits, machine performance.
Yes.
How can it be enhanced and advanced through smart solutions?
Yes, so looking into it, when you do product development, there are a few things that are critical. Time to market, short lead times, get it right the first time, and also get the quality right. So what we want to do is to improve the valve functionality. Then looking into smart hydraulics, for example, looking into a smartwatch. You have processing capability, you have a sensor, and you have communication. All those things can bring you additional value. That doesn't mean that everyone will buy a smartwatch, but for a certain segment of customers, they see those benefits that can be added with a smartwatch. They value that, and therefore they buy a smartwatch instead of a standard watch. Similar things can be done on the valve. Now, when we have sensors, processing capability, and communication on the valve, you can reduce hysteresis, add new smart functionality to improve the operation of a crane, for example, or even do other data transmission with, for example, the pressure levels from the valve up to the cloud or so. So the machine builder can utilize that data to build even better products in the future.
Without naming your customers necessarily, can you give us an example of a project where that happened?
Yes, we have a collaboration project with a customer in the US who uses ICANN system, for example, that they put on, and collaborating with the manufacturer of the engine. So they collect data, transmit to the cloud, and then can do analyze of that data. How is the products used or the machine used, to see how can we take it to the next level in the machine performance.
Okay, and do they have good outcomes with that? I mean,
yes, of course, it is in an early stage, but of course we are collecting data and can see trends how the machine operates.
And what will you do with the data mainly? What are the main benefits?
That I think is a little bit tricky to say right now.
Okay.
It's still in an analyze.
Still in research and development phase. Okay. Erik, how does the architecture change with the introduction of smart solutions?
I think what we can always do in this case is that we can, or usually, simplify the architecture significantly. I mean, we still need a controller, but the controller can do a lot of the stuff that we used to had to do in the hydraulics, so in the hardware, but we can solve it in the software nowadays, and we can tune it to a specific machine, a specific operator, whoever wants to operate it. So,
what about safety concerns there, if you're talking about software introduction?
So the safety concern, I mean, it's a very important part and something we work heavily with. But I think with a smart system, you can make it safer by monitoring the performance of the valve or the pump or whatever product we're talking about, or the whole system for that matter. By using sensors, we can have redundancy, we can have checks and diagnostics inside the valves to improve safety and make sure that all the functionality is there all the time.
Okay, with smart solutions, what are the opportunities you see there, Johann?
Yes, I will go to the next slide here.
That works. There we go.
Oh, it jumped 2 slides. Anyhow, we will stay here. I will talk about the valve. It seemed like we were missing one slide, though.
Yeah.
Yes, looking into the opportunities we have, on the valve that you can see here in the middle, there we have integrated these things that I talked about previously. You have processing capability, you have sensors, and you have communication. So have you ever tried noise cancellation on headphones? That works quite well.
Yeah.
Yeah. You can do the same thing on the valve now by sensing the pressure in the work port and see, does the hydraulic function oscillate? So we can detect the natural frequency and actively damp it out, so you get a smooth actuation of the machine. So that could really improve productivity. So the operator is less fatigued than the end of a day because he's not exposed to all these oscillations in the machine.
What other moves from hardware to software features are happening here?
So currently, what you can see here, it's one controller per section, and then it's one controller in the end that has this smart functionality and our software algorithm to enhance the functionality of a valve to give this performance improvements that I talked about. So do this noise cancellation on the hydraulic, but on the valve.
Okay.
I think I can also add, taking a couple of steps back, looking at the kind of basic functionality of the valve, we can improve quite a lot by going over to a smart valve and simplify things that we used to use a screwdriver to tune on each valve, and we can make the valve much more flexible. So you can, instead of having to go out and tune each individual, you can do it in electronics instead, and you can connect it, and you can use the programming tool to change any kind of performance capacity of the valve. So there's a lot of things we can change with the smart valves for sure.
Yeah, and I think such a thing as having the valve calibrated from factory so you can get the right speed and demand 100 liters, and you get 100 liters. So just simple things like that also brings value into the product. And looking into what we are able to offer on the industrial side, there we have digital twins and asset administration shell to be able to hand over information to the customer so they can shorten the time to market with our products. That is also coming to the mobile valves later on. Currently, we are able to generate simulation model of a configure valve, and that is something that is unique for us.
Okay, we mentioned improved consumption, or I did in the introduction, improved energy consumption. Can you give us some facts and figures there?
Numbers, it depends so much on the application, but I think we can, in general, I think we can always operate the valve in its optimal conditions based on all these sensors input, which on a conventional kind of traditional hydraulics you're not able to do. It doesn't work like that. So we can operate the system in a way so it's always operating at its most efficient operating point.
Okay. I've got here, Smart VA 300. What was it that you wanted to tell me about that?
Yes, that's the valve that you see here in the middle. It's also displayed in the digitalization booth here at Parker, where we also can speak more about digital twins and asset administration shell and what we can offer there.
You've both got some stories that you can tell of this in action. Can you share those with us now?
Do you want to start?
Yeah, I can start. So if you look at this picture here, if you look on a traditional way of activating a machine, you work with cylinder movements that create an angle. So if you should move something horizontal, you as an operator need to think about how much should I pull in this lever and this lever to get a perfect horizontal movement. By adding sensor on the crane and having a higher performance of a valve with these calibrated flows and things like that I talked about, you could do it so when the operator puts one lever, instead of working with angles on the crane, he gets crane movements, and that significantly reduces the time for the operator to become more productive. And so the training is significantly reduced for new operators, but even for experienced operators that use systems like that have higher productivity by the end of the day because it's less thinking needed to have it.
Through your research, have you got sort of average numbers that you can share?
Erik.
Improved productivity?
Much better. Let's say it like that. No, I can only echo what Johan says about these kind of functionalities. even the skilled operators, they find it much easier. You relax to operate in this way, and it's that kind of help you can get from a smart valve. You can enable those kind of functionalities, and you can tune it into however you want it to be as well.
Yeah.
I think that's a very important thing. You can't do that on a conventional hydraulic system. You need a smart valve for that.
So, yeah.
Yeah, and I can add, again, going back a couple of steps and taking the basic things. I know that our customers spend a significant amount of time with every machine that they get to tune in the valves. And with the smart valves, we can do that from factory. We can do that immediately without them having to go through that. And it's so much easier in our environment to do it, not having to have it connected to a big crane or a wheel loader or whatever it is, where you have limited space and time. So that adds a lot of value definitely to the customer, that they can just basically plug and play the valve into a system.
Yeah, and one thing that is really important on a crane like this is the symmetry. And just emphasizing what you said there, Erik, to get it calibrated, you can get the symmetry on the crane by defining it from the beginning.
Yeah. So looking into the future, what are the next steps in smart valve architecture?
I think when we look at I think we need to look more into the system. I think we don't see that on the picture anymore. But I mean, we
Do you
work
want to
with.
go back a slide?
No, it's okay.
Okay.
We obviously work with all the controllers to enable that. We also, that's the obvious thing. Also, the sensor part of things, we need to learn how to connect that with the rest of the system, of course. But also the other hydraulic components, the pumps, the coolers, the accumulators, the cylinders, it all needs to connect together. We need to find all the value that we can provide with that.
Okay.
Yeah, and we are showing it now, as we said, in the digitalization booth. So now we are launching it and hoping that the opportunities will grow from here.
Okay, where should our visitors be going to on the booth to have a look at that?
So on the middle booth, that says digitalization above.
Okay, and there they can find the VA 300
Yes.
that you showed here on the slide.
Exactly.
Okay, and you can talk them through it. All
But
right.
it's also worth mentioning that there
Yeah.
are several components that we supply that are also displayed here. The pumps, the controllers, a lot of sensors, and for sure all the electrification components, they are very tied into this same concept.
Yeah.
Okay, and so another place to look at is the shift screen here, if you want to get an overview of how that all fits in together. Do you have any questions for our experts? Feel free to put your hand up and we get a microphone coming around and we can all learn from your questions. Any questions from the audience for our experts from Sweden? Okay. Well then, I'd say thank you very much. Do have a look around the Parker booth. Talk to our experts. You still here on the booth today?
Yes.
And tomorrow.
Okay, so Johann, Erik, thank you so much for sharing your insights. Our next talk will start at 3 o'clock and we'll be exploring air cooling solutions in hydraulic systems. Join us at 3 o'clock. Thank you, gentlemen.
Thank you.